Hi students, welcome to Laksha Academy YouTube channel. Already I intimated you, I divided the semiconductors lesson into 4 parts. Part 1 is on basics of semiconductors. Part 2 is on diodes. Part 3 is on transistors. Part 4 is on logic gates. Part 3 and Part 4 are very important for entrance examinations. So now we move to that Part 4, logic gates. So in this logic gates we learn analog signals, digital signals, Boolean algebra, basic gates and or NOT gates, and NAND gate, NOR gate and XOR gate. Difference between analog signal and digital signal. And a signal in which current or voltage varies continuously with time, then that signal is said to be analog signal. A continuous signal value which at any state lies within the range of maximum value and minimum value is also termed as analog signal. Here a graph shown between the voltage and time, and V is the voltage and the maximum value of V is 5 volt and minimum value is minus 5 volt, and the value of V changes with time, and this is a sine graph, sine curve. So the value of potential changes sinusoidally with respect to time. So V can be written as V equal to V naught sine omega t, and V naught is maximum value of voltage. This you learn in detail in AC circuit chapter. Okay, V equal to V naught sine omega t, like that the current I equal to I naught sine omega t. So here the current or voltage changes continuously with time. That signal is said to be analog signal. In the second case, and in this world we have different types of questions which have only 2 answers, yes or no, right or wrong, or high or low, like that. For example, if I ask, did you understand the lesson? You may give the answer yes or no. Or if I ask, are you safe? You may give the answer that yes or no. And if I ask 2 plus 3 equal to 5, is the mathematical statement right or wrong? And you may give that right or wrong. So like that, in a small world, the statement or the possibilities are only 2 states, yes or no. Okay, so that is nothing but digital electronics, and a discontinuous signal value which appears in steps in predetermined levels rather than the continuous change is called a digital signal. A digital signal has only 2 values, 0 or 1. And in this example, for 5 volt, the value I mention as 1, and for 0 volt, the value is 0, and variation of potential with respect to time. So at initial stage it is 5 volt, that state represented by 1, and next the potential is 0 volt, so that state is represented by 0. So in digital electronics only two states are possible, those are 1 or 0. An electronic circuit which operates only in two states, on or off, is called as a digital circuit. An electrical or electronic circuit which operates only in two states is called as a digital circuit. And in digital system, the high value of potential plus 10 volt or plus 5 volt represented by on state. For on state we consider 1. For low value of voltage such as 0 volt or minus 5 volt or minus 10 volt, those are represented by the state 0 of state. Okay, so in digital system there are only two possibilities, 1 or 0. There are only two possibilities, 1 or 0. Difference between the analog signal and a digital signal. Analog signal, the value of current or voltage changes continuously with respect to time, but in digital signals we have only two values, those are 1 or 0. In lower standard mathematics you have that number systems and Hindu Arabic system, Roman number system, and decimal number system, like that. So in decimal number system we have 10 digits, those are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So in decimal number system we have 10 digits. But there is another number system, that is binary system. By means 2. So in binary system only two digits, those are 0 or 1. The total Boolean algebra are digital electronics and digital electronics linked with these two values only, binary number values 0 or 1. A number system which has only two digits, 0 and 1, is known as a binary system or binary number system, and the states on and off are represented by the digits 1 and 0 in the binary system. So in the binary system we have only two digits, those are 1 and 0. In the tabular form I have given the binary numbers for the decimal numbers 0 to 15. Okay, so the corresponding binary numbers for the decimal numbers 0 to 15 in the next, and I explain how to convert a decimal number into binary number and how to convert a binary number into a decimal number. The base of the decimal system is 10 and the base of the binary number system is 2. Base is also named as radix, you know that in our mathematics. I consider, for example, I consider a decimal number 17. How we convert a decimal number 17 into a binary number? Continuous division of that number with 2. 2 is divided, 17 is divided with 2. 2 8s are 16, so remainder is 1. I have written the remainder here, 1. Next again divide 8 with 2. 2 4s are 8. the remainder is 0. And 2 2s are 4, the remainder is 0. And 2 1s are 2, remainder is 0. So the corresponding binary number to the decimal number 17 we have to return from bottom to top. That is the procedure. And 1 0 0 0 1 base 2 is the corresponding binary number to the decimal number. So 17 base 10 equal to 1 0 0 0 1 base 2. And second example, decimal number 29, successive division by 2, divide 29 by 2, 2 14s are 28, remainder is 1. 2 7s are 14, remainder is 0. 2 3s are 6, remainder is 1. 2 1s are 2, remainder is 1. 2 zeros are 0, remainder is 1. So read the remainders from the bottom to top. So 29 base 10 equal to 1 1 1 0 1 base 2. Next decimal to binary, third example, 47. So successive division of 2, we get 47 base 10 equal to 1 0 1 1 1 1 base 2. Next, how do we convert a binary number into a decimal number? For example, 1 0 0 1 0 1 is the binary number. This is the binary number. So on the top I have written 2 power 0, 2 power 1, 2 square, 2 cube, 2 power 4, 2 power 5 from right to left. Students, you know that how to convert a binary number into decimal and a decimal to binary. For our understanding, once again I am giving that. So 1 into 2 power 5 plus 0 into 2 power 4, 0 into 2 cube, 1 into 2 square, 0 into 2 power 1, 1 into 2 power 0. 2 power 5 is 32, 32 into 1 32 plus 0 into anything 0 plus 0 into 2 cube 0, 1 into 2 square 4 and 0 into 2 power 1 0 and 1 into 2 power 0 1, 32 plus 0 plus 0 plus 4 plus 0 plus 1, which gives 37. So 1 0 0 1 0 1 base 2 is equal to 37 base 10. A Boolean algebra. George Boole developed an algebra that is called as Boolean algebra. This Boolean algebra is very useful to solve the logical problems. And we have the three logical operations, or, and, not. And these are the three logical operations. And the two values of states represent 1 or 0, 1 for true, on, high or closed, 0 for false, off, low, open. Okay, and OR operation is represented by the symbol plus. So Boolean expression read as y equal to a or b. Don't read as y equal to a plus b. Y equal to a or b. In digital electronics, you have to follow like this: y equal to a or b. So it means that if a is true or b is true, y will be true. That we will discuss. Yeah, consider the electrical circuit to explain the OR operation, and a battery and two switches and a bulb. Yeah, the switch 1 gives the state of A, switch 2 value of B, switch 1 and switch 2. And if both the switches are open, there is no meaning of electric current to the bulb. There is no allow of electric current to the bulb. The bulb is in off state. It means that if A equal to 0, B equal to 0, the value of Y equal to 0, that means off condition of the bulb. Next, A is open, B is closed. A is open means A value 0, B is closed means B value 1. What happens if A equal to 0 and B equal to 1? Now we will discuss. Okay, so if A is open and B is closed, there is flow of current to the bulb. Bulb glows. If A equal to 0, B equal to 1, Y value equal to 1. Next, third case. If A is closed and B is open. If A is closed, there is a flow of electric current through this circuit and bulb glows. So, if A equal to 1, B equal to 0, the value of Y equal to 1. In the last case, if both A and B are closed, both A and B are closed meant for A equal to 1, B equal to 1. So, current flows in these two ways. Bulb will glows. So, for A equal to 1, B equal to 1, the value of Y equal to 1. Okay. Next, AND operation. AND operation is denoted by dot. So in Boolean expression, Y equals to A and B. So to understand the AND operation, I have considered one electrical circuit. So this is electrical circuit and a battery, and I consider two switches and a bulb. And switch 1 gives the state of A and switch 2 B. If both the switch, in case 1, if both the switches are open, there is no flow of electric current to the bulb, so bulb is in off state. So if A equal to 0, B equal to 0, and Y value is also 0. In the second case, if A is open and B is closed, and there is no flow of electric current, bulb won't glow, so Y value equal to 0. So for A equal to 0, B equal to 1, Y value is also equal to 0. In the third case, if A is closed, B is open, there is no glow of bulb. So for A equal to 1, B equal to 0, Y value is 0. In the fourth case, if both A and B are closed, that means A equal to 1, B equal to 1, bulb glows, so Y equal to 1. Okay. Next, not operation. Not operation is represented by dash or bar. Y equal to A dash or A bar. Read it as not A. Yeah, when the switch is open, bulb glows. So for A equal to 0, Y value 1. And second case, if A is closed, bulb won't glow, Y equal to 0. So 0 bar 1, 1 bar 0, Boolean operation. Yeah, digital circuit analyzed with the help of Boolean algebra is called a logic gate. In a logic gate, we have two or more than two inputs, but there is only one output. There are three fundamental logic gates are possible, and those are OR gate, AND gate, and NOT gate. And the operation of the logic gate, which contains all the possible inputs and their corresponding outputs, is called a table, truth table. A table in which all possible inputs and corresponding outputs is called a truth table. So if there are n inputs in a logical circuit, there will be